purpose of this presentation is to show how the Spectrum Manager from Ray Technologies is used to enable access in use case 1. So in use case 1, the Spectrum is not based on exclusive licenses, but instead can be shared dynamically on the given geographic area. And in this demonstration, we will assume that we have only 2 channels available for simplicity, 36.0, 36.10 and 36.10, 36.20. And so in order to access Spectrum, a user first needs to either have a local license or a lease. And here on the screen what you can see is existing licenses and leases. The blue line corresponds to deployment within a within a local license. So we can visualize the list of existing licenses in the system here, and if we click on a given license, we can visualize its the frequency over which it's associated, as well as the interference threshold. So the user will be guaranteed that at any point on its deployment area, the interference threshold will not be beyond -80 dBm in that example per 10 MHz. And the granularity of local license is in this demonstration is the US county. So here you can see the whole US county associated with this local license. And if we click on a given small cell, we can see the parameter of this small cell, and including the transmission power that is allowed. Here it's, in this example, 37 dBm per megahertz. And similarly, in this example, we have leases. So if you look at on the map, here there is a lease, and similarly you can see the interference protection threshold associated with the lease, as well as its starting and expiration date, and the license associated with the lease and the owner of this license, the local license. And on the other frequency we have another local license and another deployment here that you can see. So the purpose of the scenario here is to show what happens when a new PMSC user comes in. Here, let's assume a music festival in Central Park. So here you have an overview of the process to access Spectrum for PMSC. We see it as a 2-step process because the PMSC user needs, during the whole time of its operation, need to have a guaranteed protection from interference, and its transmission power should not be modified so as to guarantee a continuity of service, a constant quality of service. So prior to operating, the PMSC user needs to first indicate to the SAS, to the Spectrum Manager, its planned deployment, so that the Spectrum Manager can identify whether there are some frequencies available that can satisfy, that will not impact other users and local licenses and leases already deployed. So based on this planned deployment, the SAS will be able to check whether this deployment will interfere beyond allowed threshold on other leases and local licenses around. And once a frequency has been found, the lease or local license can be created, and finally the PMSC user will be able to operate, in other words, register its real device and request authorization to transmit, and the SAS will enforce the license or the lease that has been agreed upon beforehand. And of course, end user device in use case 1 will then be able to connect to the small cell. And as part of this work, we filed a patent on this process. So if we are back to the map here, so the dashed line corresponds to the intended coverage area. And what the PMSE user will do is run the interference protection algorithm in order to enable the SAS to compute the interference on all the local licenses and leases that are around. So, for example, on this, what the spectrum manager will do is, for each single point within a given coverage area of a local license or lease, it will compute the aggregation of not only the new PMSE devices, but also the existing PMSE users and small cells, and check whether the interference threshold, whether the level of interference is below the threshold for this local license. And here it was minus 80 dBm per 10 megahertz. So, and it will do it, of course, for all the coverage area on all frequencies. So on the blue here, and similarly on other frequency. And the output of the algorithm will be an allowed transmission power. What is, given this constraint for interference, what can be the allowed transmission power for every single device? So we can see the results here. On the left column here, it's the transmission power requested by small cells, and on the right hand side, the output of the algorithm. And the list of small cells here are all the small cell deployed on the map, and you can see the frequency over which they transmit. So it's all the small cells, including the new one associated with the PMSE user. And what we can see is that most EIRP remains unchanged. However, here we can see that on 36.0/36.10, the frequency, the power is reduced. So it means that the arrival of this new PMSE user on 36.0/36.10 has an impact on its allowed transmission power. So therefore, this frequency cannot be used by the new PMSE user. However, on the other frequency, 3610/3620, no small cell has its transmission power reduced by the arrival of this new PMSE user. So that means the PMSE user can be allowed to create a lease, and so we will inject this lease in the system. Here it is. And so now that the PMSE user has a lease, it can start to connect its real devices and to transmit at the transmission power that was used during the simulation that I just showed. So the connection to real small cell will be part of the phase 2, and we are looking forward to connect to small cells from Acceleran to show this demonstration end-to-end as an illustration of use case 1.